Okay, students, today we are going to be talking about exponential growth and decay. And the essential question, these are things you want to be able to get from this is, can you determine the multiplier for exponential growth and decay? And can you write and evaluate exponential expressions to model growth and decay? Well, let's get right into it. So we're going to start with an exponential growth problem right here. Let's just say you took out a $200,000 30-year mortgage at a 5% interest for your new house. Your plan was to pay off the entire loan at the end of the 30 years. How much would you need to pay? Well, it's always good to highlight the important information, right? So let's start by highlighting the $200,000. That seems important. And 30-year mortgage, I guess that's important too. And even this 5% interest rate. Your plan was to pay off the entire loan at the end of 30 years, which is not normal. Usually people pay it off monthly as they go through the 30 years. But let's just say you got this loan for this, and then your question is, how much would you need to pay? Well, to solve a problem like this, you need to do these 4 steps. And the first step is determining the starting value. Well, in our situation, the starting value is $200,000. So we'll put that right here. Step 2 is to determine the multiplier. Well, the multiplier in this situation will use this 5% interest. So we're going to take this 5%, and our first step is to change that over to a decimal. And to do that, you take the 5% and divide it by 100, and that actually makes it 0.05. Now, you could also just take this decimal point and move it over to the left 2 spots, and you would get your 0.05. Next, what we need to do is, because this $200,000 is going to be increasing, we need to multiply it by a number that's greater than 1. So we're going to multiply it by 1 plus the 0.05, which is actually equal to 1.05. This is our multiplier. This is the number you're going to multiply by, this $200,000 every year. The third step is to determine the duration. In our situation, the duration is the time, and this is going to be going on for 30 years. That's right here, because it's a 30-year mortgage. Now we need to figure out what this expression is going to be. And to do that, let's use this table to figure out how we will determine this expression. We will know at time 0, the cost of this mortgage is $200,000. Now, a year later, this mortgage is going to be more. In 1 year, this mortgage is going to be not only $200,000, but 5% more than that. So that's $200,000, and you multiply that by the multiplier, the 1.05. And then on year 2, not only is this mortgage to be the same as much as the year before, the 200,000 times the 1.05, but you're going to have to multiply it again by 1.05 for this next year. And if this continues on and on and on, in 30 years, the cost of this loan is going to be $200,000 times 1.05 multiplied by itself 30 times. And the easy way to write that is using exponents. So we would say this is 1.05 raised to the 30th power. Well, this is our expression right here. That's our expression. And so let's write that down here. We got our expression for this is 200,000. Notice our starting value times 1.05. Notice that is our interest. That's how we did that. Raised to the 30th power. Notice that's our duration right there. So now let's figure out what this turns out to be. So we have 200,000 times 1.05 raised to the 30th power. That turns, holy cow. Okay, so if you can see that, we have how much you're going to pay in 30 years is $864,388.48, give or take. That is a lot of money. So this turns out to be $864,388.48. So your solution to this is, how much will you need to pay? Well, you will to pay $864,388.48.